x raised to n minus a raised to n by x minus a. What is n? N is 1 by 3. What is a? A is equal to 3. Now here if you observe carefully, this is of the form x raised to n minus a raised to n divided by x raised to n minus a raised to n. What is to prove that? To prove that limit theta tends to 0, sin theta by theta is always equal to 1, where theta is in radians. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidyashram PU College, the Temple of Excellence. In my previous class, we have discussed theorem number 1, that is limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n a to the power of n minus 1, where n is a rational number, by considering n as a positive integer, n as a negative integer, and n is a fraction. We have derived that theorem using 3 cases. Now in this session I am going to take the problems based on that, and also very important theorem number 2, that is regarding sin theta by theta. Now before going to that theorem, let me discuss few problems based on the first theorem. Now let us come to the first problem. In the previous class we have discussed the very important theorem, that is we know that limit x tends to a of x raised to n minus a raised to n by x minus a is always equal to n a to the power of n minus 1. This is what we have derived in the previous class. Now based on this, let us take some examples. Now evaluate limit x tends to 5 of x square minus 25 divided by x minus 5. This can be written as limit x tends to 5 of x square minus 25 can be written as 5 square divided by x minus 5. So if you observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n divided by x minus a. What is n? N is equal to 2. What is a? A is equal to 5. What is the formula? N a to the power of n minus 1. Limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n into a to the power of n minus 1. Here n is equal to 2 and a is equal to 5. If I apply the formula, what is n? N is 2 into a is 5 to the power of 2 minus 1. That is 2 into 5 to the power of 2 minus 1 is 1. 5 power 1 is 5 itself. 5 into 2 is equal to 10. So the value of limit is equal to 10. That's it. So 1 or 2 more questions, right? Very simple. Now let us come to the next problem. Evaluate limit x tends to minus 2 of x to the power of 3 plus 8 divided by x plus 2. Now just this can be written as limit x tends to minus 2 of x cube as it is. Now let us write plus 8 as minus of minus 8. What is minus into minus? Plus, divided by, in the denominator, x minus of minus 2. Now this can be written as limit x tends to minus 2 of x cube minus 8 can be written as minus 2 whole cube divided by x minus of minus 2. Okay, see here. So if you observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n divided by x minus a. So to apply the limit formula, it should be of the form x to the power of n minus a to the power of n divided by x minus a. So therefore convert this plus as negative sign. So plus 8 can be written as minus of minus 8, minus into minus plus. Again plus 2 can also be written as minus of minus 2 is plus 2. So convert this into the form x raised to n minus a raised to n divided by x minus a. Again this minus 2, minus 8 can also be written as minus 2 whole cube. Minus 2 whole cube is minus 2 into minus 2 into minus 2 is minus 8 itself. So divided by x minus 2. So if you observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n divided by x minus a. What is n here? N is equal to 3. And what is a? A is equal to minus 2. And what is the formula? N into a to the power of n minus 1. N is 3 into a is minus 2 to the power of 3 minus 1. This is 3 into minus 2 to the power of 3 minus 1 is 2. So that is equal to 3 into minus plus 2 2s are 4. That's equal to 12. So the simplified answer is 12. That's it. So what is n? N is 3 into a to the power of minus 2 to the power of n minus 1. 3 minus 1 is 2. Minus 2 square is plus 4. 4 into 3 is equal to 12 is the simplified answer. Hope you followed. Very simple concept. Now, let us come to the next problem. Evaluate limit x tends to 3 of x minus 3 divided by cube root of x minus cube root of 3. Now, this can also be written as limit x tends to 3 of the numerator is same x minus 3 divided by, in the denominator we can write cube root of x can be written as x to the power of 1 by 3 minus 3 to the power of 1 by 3. Now, to apply the limit, it should be of the form x raised to n minus a raised to n divided by x minus a. Now, therefore, divide by x minus 3 in numerator as well as in the denominator. Then you will get limit x tends to 3 of numerator x minus 3 by x minus 3 is 1 divided by, in the denominator, x to the power of 1 by 3 minus 3 to the power of 1 by 3 divided by x minus 3. That's it. Now, the numerator is 1 as it is, apply the limit for the denominator. So, if you observe carefully, this is of the form x raised to n minus a raised to n by x minus a. What is n? N is 1 by 3. What is a? A is equal to 3. Simplify, you will get the answer. That's it. So, here, limit x tends to 3 of x minus 3 divided by cube root of x can be written as x to the power of 1 by 3 minus cube root of 3 is 3 to the power of 1 by 3. Now, divide both numerator and denominator by x minus 3. X minus 3 gets cancelled. 1 divided by, in the denominator, x to the power of 1 by 3 minus 3 to the power of 1 by 3 divided by x minus 3. Now, applying the limit for this can be written as 1 over, in the denominator, this is of the form x raised to n minus a raised to n divided by x minus a. What is a here? N is equal to 1 by 3 and a is equal to 3. So, if you apply the formula, n into a to the power of n minus 1. 1 over n is 1 over 3 into a. What is a? A is 3 to the power of n is 1 by 3 minus 1. So, 1 divided by 1 over 3 into 3 to the power of, take LCM, 1 by 3 minus 1. That is nothing but 3 is LCM, 1 minus 3, that is equal to minus 2 by 3. 3 to the power of minus 2 by 3. Okay. Now, this can also be written as, just take this to the numerator, 3 divided by 3 to the power of minus 2 by 3. 3 to the power of minus 2 by 3. Simplify this, you will get the answer. That's it. 1 divided by 1 by 3 into 3 to the power of 1 by 3 minus 1 is minus 2 by 3. So, just transfer this to the numerator. So, 3 by 1 is 3 into divided by 3 to the power of minus 2 by 3. Again, law of indices, we can take this to the numerator. I will write here, this is equal to 3 into, just since 1 over a raised to minus m is also equal to a raised to plus m. Take this to the numerator, then this becomes 3 to the power of 2 by 3. Now, according to law of indices, what is law of indices? A to the power of m into a to the power of n is a to the power of m plus n. This is 3 to the power of 1 into 3 to the power of 2 by 3 is equal to 3 to the power of 1 plus 2 by 3. This is 3 to the power of 3 is LCM. 3 ones are 3 plus 2 is 5 by 3. So, the simplified answer is 3 to the power of 5 by 3 is the required answer. That's it. Hope you followed. So, the answer for this is 3 to the power of 5 by 3. That's it. See here, very simple. Just apply the limit. What is n? 1 by 3. What is a? 3. So, 1 over, the formula for this is na to the power of n minus 1. 1 divided by n. N is 1 by 3 into a is 3 to the power of 1 by 3 minus 1. 1 by 3 into 3 to the power of, take LCM, 1 minus 1 by 3. 1 by 3 minus 1 is minus 2 by 3. And transfer this to the numerator. 1 divided by 1 by 3 can also bring us 3 by 1 is 3. So, 3 divided by 3 to the power of minus 2 by 3. According to law of indices, 1 over a to the power of minus m is also equal to a to the power of plus m. Transfer this to the numerator. A to the power of minus 2 by 3 becomes plus 2 by 3. Again, law of indices, a raised to m into a raised to n is a to the power of m plus n. 3 to the power of 1 into 3 to the power of 2 by 3 is 3 to the power of 1 plus 2 by 3. Take LCM and simplify, that's equal to 3 into 1 is 3 plus 2 is 5. So 3 to the power of 5 by 3 is the simplified answer. Hope you followed. That's it. Now let us come to the next problem. So what is the problem here? Evaluate limit extensity of x raised to 5 by 8 minus a to the power of 5 by 8 divided by x to the power of 1 by 3 minus a to the power of 1 by 3. Now here if you observe carefully, this is of the form x raised to n minus a raised to n divided by x raised to n minus a raised to n. Now this can be evaluated by converting into the standard form. Now let us divide this. Divide by x minus a in both numerator and denominator. In both numerator and denominator. So therefore this given integral can be written as limit extends to a of x to the power of 5 by 8 minus a to the power of 5 by 8 divided by x minus a whole divided by in the denominator x to the power of 1 by 3 minus a to the power of 1 by 3 divided by x minus a. Now if you observe carefully in the numerator, what is n? N is equal to 5 by 8 and a is as it is, a is equal to a. In the denominator, n is equal to 1 by 3 and a is equal to a as it is. Now if you apply the formula na to the power of n minus 1 both in the numerator and denominator, what is n? 5 by 8 a to the power of 5 by 8 minus 1 divided by n 1 over 3 into a to the power of 1 by 3 minus 1. So this can be written as 5 by 8 as it is, a to the power of, take LCM, 5 minus 8 by 8 is minus 3 by 8 whole divided by 1 over 3 into a to the power of, take LCM, 3 is LCM, 1 minus 3 is minus 2 by 3. So this is 5 by 8 a to the power of minus 3 by 8, and when this is taken to the numerator, 3 by 1 into a to the power of minus becomes plus 2 by 3. So this can be written as 5 into 3, 15 by 8, 15 by 8 into a to the power of minus 3 by 8 plus 2 by 3. Simplify this, you will get the answer. That's it. So this is equal to 15 by 8 a to the power of, take LCM, 8 into 3, 24 is the LCM, cross multiply, minus 9 plus 4, 8 to the 16. So this is 15 by 8 into a to the power of 16 minus 9 is 7 divided by 24. This is the simplified answer. So the simplified answer is 15 by 8 a to the power of 7 by 24 is the simplified answer. That's it. Hope you followed. Right. Let us come to the next problem. What is the problem given? Limit extends to 2 of 1 over x cube minus 1 over 8 divided by x minus. So 1 over x cube minus 1 over 8 can be written as 2 cube divided by x minus 2. So this is equal to limit extends to 2 of, just take this to the numerator. This becomes x raised to minus 3 minus 2 to the power of minus 3 divided by x minus 2. So since n is a negative integer, you can take n is equal to minus 3 and a is equal to 2. What is the formula? Na to the power of n minus 1 minus 3 into a is 2 to the power of n is minus 3 minus 1. This is minus 3 into 2 to the power of minus 4 minus 3. Just bring this to the denominator, 2 to the power of 4. It is minus 3 divided by 2 raised to 4 means 2 to the 4, 4 to the 8, 8 to the 16. Minus 3 by 16 is the simplified answer. That's it. Okay. Hope you followed. So these are few problems based on the theorem number 1. Okay. Now let us come to the very important theorem, that is theorem number 2. Now this is very important theorem. You may expect this for 6 marks or sometimes maybe for 5 marks. Now what is to show that? Show that limit theta tends to 0 of sin theta by theta is equal to 1 where theta is in radians. This is called the sandwich theorem. What is to prove that? To prove that limit theta tends to 0 of sin theta by theta is always equal to 1 where theta is in radians. Now let us come to the proof. For this, let us consider a circle. Now construction part. Let us consider a circle with O as center. Consider a circle with O as center, and R is the radius of a circle. R is the radius mark the points A and B on the circle, mark the points A and B on the circle such that angle AOB is equal to theta radians, which is less than pi by 2. See here, consider a circle with O as center and R is the radius. Mark the points A and B on the circle such that angle AOB is equal to theta radians, which is less than 90 degrees. Now join OA and OB. Join OA and OB. Draw AB is also joined. Join AB. Then here AOB is a triangle, that is OAB is one triangle and AOB is a sector. This blue line indicates it's a sector. So there are two parts here. One part is AOB is a triangle, another AOB is a sector. Okay. Now draw a tangent to the circle and produce this OB to cut this tangent at C. See, draw a tangent to the circle at A, draw a tangent. A tangent is drawn to the circle at A and produce OB to cut this tangent at C. Then AOC is another triangle, big triangle. So here very simple, just if you observe carefully, the area for this triangle is more compared to the area of a sector and compared to the area of a triangle AOB. That means the area of triangle AOB is less than area of sector AOB, which is less than the big triangle AOC. Just find out the area of these three parts and simplify, you will get the result. That's it, very simple. So what is the construction part here? Let us consider a circle with O as center. I will write main points here. Consider a circle, consider a circle with O as center, and R is the radius, mark the points A and B, mark the points A and B on the circle, mark the points A and B on the circle such that angle AOB is equal to theta radians less than pi by 2. Now join OA, OB and AB. That's all. Join OA, OB and AB. At A, draw a tangent. At A, draw a tangent to the circle. At A, draw a tangent to the circle and produce OB to cut the tangent at C. See, at A, draw a tangent to the circle, produce OB to cut this tangent at C. Now finally draw BN perpendicular to OA. BN is drawn perpendicular to OA. That's it. This is the construction part. Okay, listen. Consider a circle with O as center and R is the radius. Mark the points A and B on the circle. Join such that angle AOB is equal to theta radians less than pi by 2. Join OA, OB and AB. Again, at A, draw a tangent to the circle and produce OB to cut this tangent at C. Now finally draw a perpendicular. BN is drawn perpendicular to OA. Now from figure, we can write from figure, area of triangle AOB is less than area of sector AOB, which is less than area of triangle AOC. That is, from figure, I will write here, from figure, area of triangle AOB is less than area of sector AOB, which is less than area of triangle AOC. Right. See here, area of triangle AOB is less than area of sector AOB, which is less than area of triangle AOC. Now find out, so you know the area of a sector, find out the area of triangle AOB and AOC. Now here, what is the triangle? From this triangle OAB, from triangle OAB. Let me write the triangle. This is OAB. A and B. This is the perpendicular, BN is the perpendicular, this is theta, this is BN. Now from this triangle, find out the value of sine theta. What is sine theta from this? This is opposite and hypotenuse. Sine theta is equal to opposite divided by hypotenuse. What is opposite here? BN is the opposite and hypotenuse is equal to OB is the hypotenuse. If we cross multiply this, BN is equal to OB into sine theta. Substitute here. Now what is the area of a triangle? Area of a triangle is equal to, the area of triangle is equal to, area of triangle is equal to half into base. Base is equal to OA into height is BN. So this is equal to half into, what is OA? OA is R. BN is equal to OB. What is this OB? OB is also equal to R into sine theta. So this is nothing but half R square sine theta. Substitute here. Area of triangle is equal to half R square sine theta, which is less than, now here this is the sector. See here, this OAB is the sector. This is the sector OAB. OAB is the sector. This is the radius. The area of this sector, area of sector is equal to half R square theta. Since area of a sector is always equal to half R square into theta, so therefore area of a sector is half R square theta, which is less than, come to the big triangle here. OAC is the triangle. Since this is a tangent, find out tan theta from this. What is tan theta? Tan theta is equal to AC divided by OA. Cross multiply. If you cross multiply it, OA into tan theta is equal to AC. Now what is the area of this triangle? The area of this triangle area of triangle AOC or OAC is equal to half into OA into AC. Half into base into height. This is half into OA is equal to R into, what is AC? AC is also equal to R tan theta. This is R tan theta. This can be written as half R square tan theta. Substitute here. So area of triangle AOC is also equal to half R square tan theta. That's it. Okay. Now just see here, from triangle AOB, you will get area of a triangle AOB is equal to, area of a triangle AOB is equal to half into base into height, that is half into OA into BN, that is half into R sine theta is half R square sine theta we will get. Similarly, the area of a sector AOB is equal to, that is derived expression half R square theta, and from this triangle AOC, area of a triangle is equal to half into base is OA into height is AC, OA into AC, that is half into R tan theta, that is half R square tan theta. Substitute here. So half R square sine theta less than half R square theta, which is less than half R square tan theta. Now divide throughout by half R square. Half R square is the common factor. Divide by half R square, what you will get? Sine theta less than tan theta. Now this can also be written as, that is sine theta less than tan theta. So this sine theta as it is less than tan theta can also be written as sine theta by cos theta. Now let us divide throughout by sine theta. Divide throughout by sine theta. So sine theta by theta is 1 less than theta by sine theta, which is less than sine theta gets cancelled, 1 by cos theta. Now reciprocate this. Reciprocating. So by reciprocating, you know, if A is less than B implies if you reciprocate this, you will get 1 over A is greater than 1 by B. See, for example, so you know 2 is less than 3, which implies if you reciprocate 1 by 2 is greater than 1 by 3. This is the concept. So reciprocating if A is less than B implies 1 over A is greater than 1 by B. The reciprocal of this is 1 by 1, which is greater than sin theta by theta, which is greater than cos theta by 1. Okay, that is nothing but that is 1 greater than sin theta by theta, which is greater than cos theta. Okay. Now, when theta tends to 0, then this cos theta tends to cos 0. What is cos 0? Sin 0, 0. Cos 0 is equal to 1. That is 1 is greater than sin theta by theta, which is greater than 1 when theta tends to 0. That means the value of sin theta by theta lies between 1 and 1. Lies between 1 and 1 means that is nothing but 1. That is the sandwich. So, sin theta by theta lies between 1 and 1. Therefore, the value of sin theta by theta is equal to 1 when theta tends to 0. So, if a value lies between 1 and 1 means definitely it is in the same value, that is in 1 itself. So, therefore, that can be written as, that is 1 greater than sin theta by theta, which is greater than 1 when theta tends to 0. That means the value of sin theta by theta lies between 1 and 1 when theta tends to 0. That means sin theta by theta, this sin theta by theta is also equal to 1 when limit theta tends to 0. This is called the sandwich theorem. So, the value of sin theta by theta lies between 1 and cos theta, that means lies between 1 and 1 when theta tends to 0. So, that means this is also equal to 1. The value of sin theta by theta is also equal to 1 when theta tends to 0 is denoted as. Therefore, the final conclusion is limit theta tends to 0 of sin theta by theta is always equal to 1. Sin theta by theta or theta by sin theta is also equal to 1. So, similarly, you can write limit theta tends to 0 of tan theta by theta is also equal to 1. Sin theta by theta is also equal to 1 or tan theta by theta is also equal to 1. That's all. So, this is called your sandwich theorem. Hope you followed. This is very, very important theorem. Definitely you will get either theorem number 1 or theorem number 2 for your final examination. Okay. Here limit theta tends to 0 of sin theta by theta is 1. So, similarly limit theta tends to 0 of tan theta by theta is also equal to 1. If you want to verify, limit theta tends to 0 of tan theta can be written as sin theta by cos theta whole divided by theta, or this can be written as limit theta tends to 0 of sin theta by theta into 1 by cos theta. What is sin theta by theta is 1 by cos 0. What is cos 0? 1 by 1. Sin 0, 0 is cos 0 is 1. 1 into 1 is equal to 1. So, therefore, limit theta tends to 0 of tan theta by theta is also equal to 1. That's all. So, that is regarding the sandwich theorem is concerned. So, this is very important theorem. Hope you followed this, right? That's all regarding today's session. Let us meet with the problems based on these two theorems in the next session. Thank you very much.